Hi there. Well, this video is a demonstration of the POC for EMS framework. So this is created in .NET, holding the core of the functionality, and the stubs are created in BusinessWorks basically. So here are a few features of the POC. Where you have the .NET applications as service provider, try and forget and request supply. So these are the few bullets which characterize the POC when the .NET applications are acting as a service provider. So here, as you can see, connection parameters like EMS, URL, are all in configuration, which is used by framework DLL, and also the consumer code that executes as an executable and uses also the DLL. This is a queue on which the asynchronous consumers would be listening, and this is the typical general name for the consumer, which is supposed to consume messages on, of course, EMS queue, and consume messages for report like DLD, etc. So it's going by the typical naming conventions of IFS for the reports. This number of sessions and the queue name are the two configurable parameters for the consumer, and this parameter specifies the simultaneous sessions or threads in .NET that can be created for the consumer. And TIPCO designer acting as a stub sends the request and receive the messages. So it sends a request on this queue and receives the messages, or receives the replies, if any, on the temporary reply queue. So of course, since TIPCO designer has to also communicate via EMS, it will create its own separate EMS connection object in its own process space. And of course, TIPCO designer and .NET applications, .NET consumers are all running in different process spaces. So for that reason, they have to create as many EMS connections. So here is the picture, big picture of the POC. So this is your designer, which will open the project, which is basically a set of test stubs for the EMS framework POC. Of course, this is the EMS server on which the consumers and producers will send and consume messages, and this is the configuration used both by DLL and the executable, consumer executable, for connection by DLL, and for these two parameters for consumer, you name a number of sessions by this consumer. So this is what are we going to demonstrate initially. So this is the consumer, and we have two types of consumers here. One is using the message listening mechanism, and other is using the message handling mechanism. Okay. And then we have a third class which basically creates the consumer of what type as you want, and also has a small which gets called someone here. Or here, I suppose. Yeah. So, yeah. So these are the two consumers of different types, and this is a class which is entry point into the whole project and creates one of the two consumers. So here we are using delegate consumer. We can also create the message listener type consumer. So now let me start the EMS server and let me connect using administration tool. So if I want to show connections, there is only one connection, which is that of this administration tool itself, and it is of type C. So this C means C language, and this L means the language that is written in. Okay, and these are the versions of the application that are connecting. This is the connection ID. This is the type. So this type is A means this type A means admin. This is the host. This is the IP address. Of course, it's for all the IPs on this host. User is the administration admin user. Number of session is 1. Number of range is 1. Consumer is 1. Temporary queue. This is the temporary queue, which is if you wish see. So if you want, I can show you the. So this is the temporary queue on which this administration tool is working on. This is the EMS server. So now what we'll do is we'll just try to run this. So we have this consumer portal as an executable available for executing over a command line, through the command line. So I'm going to try to run this. Okay. So now I think it has been able to create a connection. Yeah. This is the second one that's coming. And if you see, this hash, it means that this connection is created by a consumer written in C# language, whereas this one was created by a consumer written in C language. Okay. So if you can see the client ID of IFS. Probably I have used it somewhere. Yeah. So if you see the client ID, this is the IFS client ID, which you can see here. This is the IFS client ID. Of course, the client ID for the connection used by administration tool is null. Okay. I think there are lots of comments or the console IOs which I have probably commented out. And this is the piece of code that will be executed when you have the messages coming into the consumer. So this on message will be fired up with this argument, with whatever messages that's received, and you can implement this function, and whatever that implementation is, that particular code implementation will be executed. So here, I've made a check whether it contains a reply to queue name. So if it is not null, that means the sender or the message producer is expecting a reply. And if it's null, then of course you just simply say that there's no message reply that's required here. Okay. So now you can see there are 1, 2, 3, 4, 5, 6 consumers that are created using connection ID 3. Okay. And these all 6 consumers are listening on the same queue. So if number of sessions I have specified here is 6. And of course, the queue name is also cam.q1. Okay. So there are 6 connections. And acknowledgement mode is client acknowledgement mode. Okay. So there are of course certain other parameters, free receivers, etc., which we'll probably talk about later. So there are no messages received, no acknowledgement made on these 6 receivers or 6 consumers as yet. So each consumer has a different consumer ID, same connection ID, and different session IDs. So essentially, in this particular pattern that's implemented using C#, every consumer will be allocated separate session, which means separate thread. Okay. So in all, there will be 6 threads created. So this is the the creator of the consumer, which basically gets the queue name and the number of sessions and passes both to them to the queue name and the number of sessions to this type of consumer constructor, and then also set the current thread name as this one, where it will be meaning that it will be current process name and the process ID. So the current process name is consumer for DLDXX.exe or simply consumers for DLDXXX. Okay, and the process ID will be like .4832. So the current thread name will be DLDXXX dash 4832. Okay. So this is a very important step that should be done, should be carried out before you start tracing the consumer creation process, so that it helps in your debugging at least. So this can be used in test environment or dev environment for debugging purposes. Maybe you do not want to use it in production, but I think it doesn't carry any overhead. You can do some database logging for current threads, for the message IDs, for the consumer IDs, for even the session IDs, queue names, etc., etc. Okay. So now what I will do, I will just try to send a message. Or what I can do is probably I have not called that function, which will make things even better. Let me do this first. So if and I'll stop this, okay. You will see only one connection now, or one consumer now. Okay. So which means that this single exe had created these many consumers. Okay, all listening on. But now since I've killed it, okay, there's no consumer for DLDXX running, so there is no consumer except for the consumer created by administrators too. Okay. So let me here now. Why I kill this? Because I want to use another function called print consumers. But where is that? I think I've moved it in the DLL of for the connection. I think so. Where is it? Yeah, this is the one. Okay. So let me try to call this somewhere here. It's a static function. No, it's not a static function. So maybe I can try calling it somewhere here. Let me create okay. Yep. Here you go. And build it. Well succeeded. Where is the output? I think here it is. Okay. So if you see, so it has been created with the latest timestamp. So if I run it again, yeah. So here you would see, there are 5 to the bugs statements which are repeated. Connection ID is 4, consumer ID is 8, session ID is 9, this is the destination name, and this is the thread name. The current or the main thread that's been used to call this. Okay, so this is the main thread that has been executed. For executing this particular piece of code, including the constructor. So constructor gets called in this thread, okay, which is this. So here if you see 6MC2 would be the process ID of that. Here. Okay. So now, and you can see also here, so there are 6 sessions on 10.q1. So each session 8, 9, 10, 11, 12, 13, which is what you get to see here. Session ID 9, 10, okay, 11, 12, 13, etc. So these are all there, documented. So this is the code which produces, um, yeah. So this is the code which produces the consumer's details. So here also we use or here only I would say, the admin object or the admin connection, which creates the admin connection here basically, and then gets the list of consumers and then brings the details of consumer like this. So that's what's being done here. Okay. So now what we are supposed to do, now that we have the consumer ready, okay, we will send the message, say one message at a time, okay, send message. So it's a find format publisher or producer, which will publish on test queue. And this test queue is this, temp.q1. Okay. So I have put a loop here, but it can send as many messages as specified in this count of messages. And at the moment, count of messages is just 1. So it will send only one message to temp.q1. Okay. And there is also a requester it sends a request on the same queue if I want. Okay. And of course, I can show you the body of the message that I will send. So RR text message from BW project. This is the project name, job ID. This is the job ID, and then the current process name, whatever that is. You get it. That will be sent by this. And in the send message, you will have the same stuff being sent except for that it's the FF message. Okay. Everything else will be the same. So let me file them both at the same time. Oh, sorry. Yeah, I think the answer is already started. So let me send one message. It's gone. So send that message. On what? On m.q1, and in return, it gets the message ID from EMS server, mind you. Okay? It gets the message ID from EMS server. So this is, and let me show you the connection also, connection details. So this is the GM connection. It's using username admin, null password, and then it's using the GMDI to look up into the lookup service, using the lookup service to get the names, to get the objects and names of these two factories. So here, for creating key connections, we will be using this key connection factory in TIPCO Designer. Okay. Yeah. Why are you already this? Sorry. Yeah. So why it says fail is because client ID, which is TIPCO Designer, is already there. If you see, this is the one. Okay. So this is an IFS which is created by the consumers of C#, and this is the client which is created by TIPCO Designer. Okay. So now I have published this message. Okay. And a consumer, which is I think this, has received it. So message received by thread EMS session dispatcher 9. Now this is interesting. So it's not the same thread now. It is not this thread that has received it, but this thread. So session ID 9 is responsible for capturing this message, and corresponding to the session ID 9, there is a thread called EMS session dispatcher 9 created. So if you see the code of on message, since your reply is of course, this is null, it will come here and say that no reply support, and thread name is this. So that's what it has done. No reply short follow-up message and reply queue is null, thread name is this, and this is the message that's received. So same thing, Job ID is what? 63,000, and the process name is producer send message process. Okay, so this is sent, and of course the header also is displayed. The header with message ID is same as this, not of course. Yeah, same as this one. Okay. So now the consumer and the producer both know that they have sent and received a message of message ID this. Okay. if you see here, it's the same message ID. This is from the consumer, and let me see from here. Yeah, so this is just a namespace kind of thing. So you can see it's identical. Okay, you can ignore that, of course. It's basically a qualifier that's showing it's an ID. And message ID destination is coming from a system.q1, which is a queue, and reply to is null. That means it's not expecting any reply. The variable is persistent. That means it should persist the messages and delete only when it receives the acknowledgement. Pre-delivery is false. That means not delivered more than once. And these are other properties. And expiration is always infinity, and priority is 4, which is the amount of priorities associated with the message. And this is the body of the message. And as you can see, no reply stop for robot meta reply queue is null. Thread name is this. Okay. So now if I want to send as many messages, and then I'm going to send 4, I have to just increase the auto message to be sent to 4, and it will send 4 messages. Okay. So this gets executed. Yeah. So this is the code that gets executed. And then the message. Okay. So now if I want, so now if I see the consumers, so you will see on this one, on session ID 9, okay, there was corresponding thread created. One message has been sent and acknowledged. So how is it acknowledged? Using this. So if it is not expecting any reply, which means it will come here, okay, and then it will acknowledge it. So in both the cases, in request apply as well as in FF, this is request apply in the processing kind of thing, and this is FF, but for both of them, the acknowledgement has to be made. So this is what has been acknowledged. Okay. So there is only one message sent and one acknowledged by session ID 9 over 10.q1. Now let me send the request. So let me send the request. Oh, it's gone. So this one got held up because I had used this. So the screen got kind of locked and it wanted to print, it could not. So I had to create a new set of requesters. But anyway, so if you see the last message, which is this one was a request message from the previous session, which I have to, kill, because it could not print on the screen because the screen was locked off this reason. It could not print, and it got timed out. The request got timed out because it could not get the proper reply in time from the consumer. But this one is gone fine. So if you see the input data, So the request is sent from this, job ID is this, and if you see here, message replied by this thread is now 12. Okay, 12 is the session ID. This is the one that's same thing that's sent. Okay, same, right? 65,000, and this will be 65,000. Okay, and then the reply has been sent is just the same. How the same message sent back, the reply sent back is here. So if it is a message reply to is not null, then it will create a session for sending back the reply. Mind you, it cannot use the same session because not this session, because it's meant for consumption. But now you have to send a reply, you will have to create your own new session. And this session is created through the connection, single connection that's created at the startup time, okay, and it's a static connection. And here the acknowledgement is auto because generally for sending the requests, sending the responses, we use auto as the acknowledgement mode because we have anyway received the original request message and which we have acknowledged also using this. But while sending the response back, we generally use the auto mode, which means that the acknowledgement is automatic and you need not use any, or the receiving party need not use explicitly this call. So whatever the message that came is, concatenated with few other stuff, and then this message is created again using session, and then reply of text is assigned, of the text of reply is assigned with this, and reply is sent. Using this particular function. The reply message and reply to queue are the two parameters for sending back the reply. And if you see, it should be able to receive. Now this is the message that was sent. You see the input data and output data will be something like this. Equaling back the received, whatever it is. So replying process name is this, processing ID is 6932. Thread name, that, of course, this thread name is not the thread that's including BusinessWorks. That's thread name coming from the consumer, and this is the client ID IFS, and the new producer session ID was 45. Okay. So this reply message, I can show you. Where is it? I think that's send reply message. This is the one that's used. Okay. It will create a new session, and then it will send back the reply. Okay. So that's what's in the feed. Now if I want to send this one again, I'll get this. This is an SF1, and it will only get the message ID that would not come from consumer but from the AMS server. And of course, this is the message that has been sent. 65001 is the first ID, and if you see here, sorry. So this consumer is receiving messages over time.q1, and it's basically just echoing the messages on screen, and also, if required, sending the same message back to the requester. So now if I want to send multiple messages at a time, just have to increase the number assigned to the count of messages. This is the one, so it's only one. Let me send 4 at a time, or let me send 7 at a time, and you'll see what happens. Okay, now let me send this. So it has sent about 7 messages. Okay, because the value of I, that's the variable for count, is 7, but as soon as it gets more than 7, it hits loop. So here we'll see that all the messages, 1, 2, I don't know, 1, 2, 3, 4, 5, 6, I think 7 have been sent. So, and all of them, it's difficult to count, I don't know. But yeah, I'm definitely sure they are 7. Because of, so every message is received by, different thread. Again, coming to 11, and then 12, and then 13, and okay. So there are 6 sessions with 6 corresponding threads, and it has processed 7 messages, which means that first 6 messages were processed concurrently. 7th message had to wait for any other threads to get free for its turn for processing. Okay? Because the number of sessions is, I think, is how many? 6? Yeah, it's 6. Okay? Yeah. Mm-hmm. Now if I send the 7 requests, oh, great, goes. This is the last request that's sent. I would not be able to show you the first 6 or 7 messages that were sent. They were all sent in loops. It will only show the last one, unless I do something like accumulate output. I think it's already, okay, I can show you that, yeah. Okay, file data. What's the, replies is the name of the job slot, so I definitely can show you that then. So replies, yeah. So this is the first one, second one, third one, fourth, fifth, sixth, seventh. So there are 7 responses received, and as you can see, these are the 7 requests coming from here. The reply has been sent, reply has been sent, reply has been sent, and these are the threads. Sent. Yes. Okay. So if you see the last one, reply 80, and yeah, session 9. This is the last one. I can show you in the process data also. I think. Yeah, this is the body. Okay. so, so the message that was received was this one. Say for example, last message. Let's see. Well, it's easy to see the last message. So it's saying reply to. This is the temporary queue. So as soon as it sends the last message, and of course the other messages also, the previous messages also, it waits on this queue. Okay? And then gets back the reply. That's the same queue. Just the same. Okay? Fine. So there are 6 threads created, and all 6 threads are used simultaneously to process the message and send back the reply. And again, let me show you. So this is the line of code that gets executed first as and when the message is received. And then it checks whether the reply queue is null or not. If it's null, then it goes here. That means it is a FNF message, it is simply prints it. And if its reply queue is not null, that means that on the other side, the reply has been expected, so it will do this stuff. It will just, concatenate other stuff like this with the original message and send back the message. Okay? So this is what a small POC is about, and I think we should build on that to, make it more extensive. Not extensible maybe, but extensive, yes. And more versatile, so that, it is able to process and receive messages in all scenarios, messages of all types, of course. So I think what I can do is I can send these. Oh, shit. I can send this. I should have, redirected output of the file rather than copy and pasting from here. But anyway, no issues. Not all messages have come because it's just scrolled down a lot and I could not scroll back up to the beginning. So probably you will miss some of the logs, but anyway, it doesn't matter much. So I have killed the consumer, and it shows only the one consumer that was there. That's there from the beginning. Of course, this is out of administration tool. So mind you, of course, this administration tool also uses VMS queues to send and receive messages. Okay. So that was the basically synchronous consumer acting, and then there are the relevant screenshots. Of these, which I have already sent before. So now here we can also show you your .NET application acting as a producer, as in file and format and RR. For that, I have to open this one, which is a small desktop, I would say, which basically, is a producer of messages. Basically, it's sending the request reply or using the request reply mechanism, synchronous one. Okay, so let's try this out. I think it should work. I think, yeah, it's there. Let me first get to know what I've forgotten what I've written about it, because I wrote it a long time back. So it creates a queue session, and then yeah, it gets the queue name, which is, I think, this one. Yep, queue name. Then creates a message hello there, and then sends the process name and its ID and current method name also, if it ever works. So then if the reply is text message, it writes the reply. Because probably you can write only the text messages on the screen on the console. So let me now before I start this, okay, I'll have to start the consumer first. So I have the consumers here. Yep. So this is the one which does not reply back, and this one it does. Okay. And what is the reply back? Looking back the message, the same message, text received, and of course it depends the current thread name, which is a thread name in the business works, and the process name, which is the process name of the business work, which is this one. Okay. So let me try this one. Yeah, I think let's hold on. Okay. So if you see, now this one is the consumer that tapped into the EMS. Now let me see if what it shows. Yeah. So it is again has 6 connections, 6 session ID, sorry, using the same connection ID and different session IDs, different consumer IDs and different session IDs tabbed into Canvas Q1. Okay. So the number of sessions here also have put as number of session allowed. It has, I think, 6. Yep. So it will get 6 sessions. So now I can try to run this. There you go. They send a message and receive the reply back. Yep. So this was the one that was sent, or received by this one, and sent by this one. So this is about to send message. So this was what was sent. Hello there, and then the framework 632 with name. So this is the process name, or the OS process name. This is the process ID, and this is the function name. Okay. OS process name, OS process ID, and the function name. Of course, if you want to see it from Task Manager, you won't be able to see it because it's only a producer. It sent a message, received a reply, and went off according as it is coded. Okay? So it's just, seeing and echoing or, printing the message, and it's going off. So, of course, you won't be seeing the document. But this one, of course, it will be there all the time, listening to the queue. So it was one message and then one acknowledged. That's about it. Okay. But what was the reply sent? So current thread here is job core 1. Well, that's the internal threading of BusinessWorks, which is slightly different from what we have coded, okay, or what we want in .NET. But I've also created some synchronous consumers. Probably I'll show you later the how when it sees that it's a synchronous consumer. I'm talking about BusinessWorks only. It tends to create threads, internal threads, and that leads to multi-threading. But it's all transparent to the user. For this, for this function, let me show you. I have used these 2 minutes. So step element has been used to get the same information. Okay, so and it's here. So this has been used. The class has been used. This class has been used and imported. So basically, typical BusinessWorks and other products are mostly Java-based, and interoperability between Java-based products and .NET-based products here can be achieved through EMS also. Okay. Awesome, it doesn't do anything. It's just to show, just for illustration purpose. Okay, and then it's confirmed. The message is confirmed to the change leadership from where it's received. So if you see, that has been sent, echoing back the message, exactly the same has been sent along with the BusinessWorks thread information and the process name information, and which you will see here. So thread name is Job Courier 7. You will see somewhere that it's Job Courier 7. You see this. You see this too. Here too. Okay. So this is one of the examples, and I think pretty much what we'll be doing even in the regular development requirements for interacting with the EMS for sending and receiving messages. Any questions? Please get back to me on okay. I would expect some questions on this. Okay. So see you sometime later, and bye for now.